So we have a 30 centimeter long string on a violin. It's all tuned to play the note A. The note A has a frequency of 440 hertz. Once the instrument's all tuned, if we want to play other notes, we need to put our finger on the string. So I would like to know where we need to put our finger in order to play a note with a frequency of 560 hertz. Sorry, kind of ugly. I am assuming this 30 centimeter long string means it's 30 centimeters from the bridge to where it passes over to go to the pegs. So the 30 centimeters is the length of it that can actually oscillate. So here's our string. That's the 30 centimeters. When we place our fingers on the string, if you push down on the string somewhere, that only allows this segment of the string to vibrate. So if you shorten the string, that decreases the wavelength. What will that do to the frequency? It'll increase it, bring it up. Exactly right. Because the speed of the wave isn't changing. We would have to play with the pegs to loosen or tighten the string to change the speed of the wave. So, how should we go about finding where to put our fingers? Basically, how long to make that segment.
You have the frequency of the wave, just not the velocity, so you can plug that in, find the velocity, and then you have the new velocity, or the new frequency and the original velocity.
That will work great. So we know the frequency, and we can certainly find the wavelength. So this original frequency is 440 hertz. What's the original wavelength? So wave on the string, wavelength 2L over M. Whatever, when we say an instrument is playing a certain note, it's the fundamental, so M is 1. So wavelength's 2L, so 60 centimeters. Exactly right. And yes, the speed of the wave is the wavelength times the frequency. So 440 hertz times 60 centimeters. Now, before you grouch at me about units, because that's not going to give me meters per second. If we know the speed of the wave is going to be constant, then we can simply say wavelength times frequency original has to equal wavelength times frequency final, right? So final or new wavelength times the new frequency. That's just going to give us our new wavelength in centimeters as well. So since I'm not taking the time to solve for what V actually is, we don't have to worry about the units. So 47 centimeters. It's actually 47.1, just a little beyond. So the new wavelength is 40 centimeters. That's what we need it to be in order to play this note at 560 hertz. So how long does the segment of the string now need to be to have a wavelength of 47 centimeters? Half of that. 23.5? So this segment of the string now is 23.5 centimeters. That will allow just that segment of the string to vibrate. So we'll hear a higher pitch. We'll hear the 560 by placing our fingers 23.5 centimeters from the bridge. Or 30 minus 23.5, 6.5 centimeters from the neck.
So where did you get that 47 centimeters from?
Calculating this. Multiply these two numbers together, divide by 560.
How do you know that it's the
whatever an instrument plays, it's always going to be the fundamental. Whatever note you're hearing from the instrument, unless you're forcing a harmonic. You can force the harmonics out by putting your finger lightly, but if we just talk about an instrument just normally playing a note, it will always be the fundamental.
So if you were at, say, 22 centimeters instead of 23.5, would you end up in between fundamental notes?
No, it would just play a different frequency.
Okay.
Still fundamental.
It would still be a fundamental, yes.
So it's still complete.
Yeah, it would still be completely a fundamental.
Okay.
It would just be a different pitch, a different frequency that you would hear.
So how would you not be a fundamental? How would you can't really stop?
The only way you cannot be a fundamental
is
is if you put your finger really lightly on the string. If you put your finger really lightly on the string, that allows both segments to continue to vibrate.
They cancel each other a bit.
It's not that they cancel, it's just that now you're forcing two antinodes to be there, so you're forcing the second harmonic out of it.
So that acts like a note.
Yeah, your finger acts as a note, exactly. It forces a note to be right there. But that only works if you just very lightly touch the string. Okay. So if you're doing anything other than lightly touching the string, you always have a fundamental.